this whole thing will go, right?
Who this all team got it up? What is this? Oh, it's transcribing. Okay. Entire screen. This one. This one only, no?
Like in this display I have put with
Include
note
sound.
with note.
Which one?
Yeah, that's great.
This one. Yeah, it is sharing this one only.
I want to get the other thing.
அது இங்க பண்ணிக்கலாம். இங்க இது
It is in a new tab, a new window. Here, can you check here?
இதா
No.
இதா
In the Safari only, but it is a new tab.
இதா
Presenter view.
ஓகே. அது இப்படியே பண்ணலாம். You can actually do this. 3 fingers.
Big crowd, sir. Big crowd.
Oh, can you minimize that thing in the screen? But it's not.
Click.
Okay.
You can explain the gist of it.
Oh.
Explain the gist of it. What is this equipment all about? We will see that also.
Yeah. Okay, the device is used to like display 3D models in actual 3D form as we view a 3D object itself. Like the usual 3D display, we just feel as a perceivable 3D view. In 3D view, you see the depth is coming to us. But in this display, we can walk around the display and see if object is displayed, actual object is being displayed in the display. So you can view the different parts of the 3D object being displayed by walking around the display. Like that's an action.
Around the display.
Like if you place if this keyboard is placed here, if some people have to see this like all around, we can walk around this object, right? So in this display also we can supply the 3D model, we can walk around the display and we can see the object as it is.
For example, there is an elephant. You go around the elephant and see the complete elephant.
Yeah.
Right. So here you tell me the same analogy.
Yeah, it's like if we give a 3D model of elephant to the display, so while showing, you can walk around the display, then you can see it as elephant, like the different parts of elephant, like a 3D object elephant is
So it has a screen backside also.
Yeah, it's in that side also. And it will rotate. So in between it will create frames.
Basically, you took an image and then you wrote a code for it such that it can convert 2D to 3D.
I know it's like we are giving 3D models. It's not a JPEG we are giving. We are giving a model, any 3D model, maybe architecture for a 3D model for any 3D model. Then we have made a software to convert that 3D model can be viewed in this way. And it displays a driver that can read that file. It will show that 3D model at that's it.
I cannot. Okay. என்ன வீணா ஜாயின் பண்ணுது?
Yeah, I had sent to your friends.
ஹலோ, இந்த ஒரு நிமிஷம் இருந்தா வரேன். கேன் சம்மன் பிரிங் அஸ்வின்? எங்க இருக்க இப்ப? ஓகே இருந்தா வரேன். இந்தா வரேன்.
Recording it or transmitting? Then you will put it in your YouTube.
It is yes for documentation.
Okay, I think we'll start. He's stuck. I guess. He's stuck because he's not able to find that. So now I'm using all video call. He's going after 50 level. He's going and then it's full of solar panel. I think that peak value bit. இல்ல நான் 50 இருக்கேன். இந்த லெவல் இருக்குல்ல, இந்த லிஃப்ட் லெவல் அதுல 50 காட்டுது. ஆனா மேல வந்து ஏறினா சோலார் பேனல் இருக்கு.
It's become God, sir.
So start. We'll start. We will join.
Okay.
I asked Pawan to bring him some.
Okay.
So first of all, yeah, welcome everyone for Jabeen's thesis, master's thesis, and so he has worked on unique product that some of you guys might have actually seen in some Insta reels and some of might not have. So it's a kind of hologram, but we are rendering the 3D model in different way using persistence coefficient. So first of all, thanks to Professor Ram Kumar and Professor Satyaki will be joining online, and uh, R.S. Ashwin Kumar, he is actually faculty of technical. Yes,
Lost somewhere.
yeah, he's lost somewhere in this building architecture. And then once we teleport him here, meanwhile, he'll actually start with the presentation. So he will join us later. First of all, thank you, Jabeen, for setting up the entire thing. So you will also be after the presentation, you will have a chance to look at the product of how it is working. Whomever is interested or any inputs or collaborations. Okay. Yeah, now it's up to Jabeen.
Okay. Good evening, all. Thank you for coming to the presentation. For those who don't know me, I am Jabeen Sultan, and I am a second year MDes student. Is the sound audible to all of you? Louder. Okay. Okay. So my thesis topic is on a 3D volumetric rotating LED array display. So it's basically in a short terminology, we can say if we supply a 3D model to the display, then it will show, this display will show that object as a actual 3D object. Like for an object in front of us, we can walk around the object, we can see different parts of it. So in this display also, we can walk around the display and see whatever 3D object being supplied. So I would like to present this as a story only, like how we got into the idea, like how we developed, what all challenges came here. So before that, I would like to thank those people who helped me to achieve, to do this project. First of all, I will thank my professor Gautam Prabhakar, who is my guide and who was very supportive in all aspects of this project, even like mentally, financially, in all aspects, and I thank him very much. And I would like to thank Professor Ramkumar sir, because he helped with 3D printing all these things. Like in our department, printer was not good at that time. Now also it's not good. So I would request Satyaki sir to get new printers for the coming batch, or it will be so helpful. And he helped with his own printer. It's very thankful. Thank you, sir. And I will ask more prints also later. Okay, then I will do like Ashish Saini, who is a student in material science department, who also helped to get 3D prints done. I want to thank Aglesh, who is an intern, who was an ex-intern, but he again came back here in the HIVE lab. He helped in hardware things. And thanks to all, like in all members of the HIVE lab, Anandu, Rashmi, Rajshekhar, all the ex-interns and all the current interns in the lab, and to my parents also, and thank God also. So we'll start. So actually, this idea came up in a way like first in the first semester of the my thesis, I was planning to make something else like a VR gaming workout kind of a game. But during the second semester, like Gautam in his house, we were talking about how the 3D TVs are working, like the 3D glasses were working. So he said to me like how the functionality, and he said it's not true 3D. We are just feeling a depth of that. Then I asked him whether there is a like holographic fan in the HIVE lab. So I asked him, it's also 3D, right? And he said it's not 3D, it's 2D actually. You are just feeling it as 3D in the dark environment. Then I asked him, so is there nothing like to show actual 3D objects? Then he also at that time he also didn't know. So I talked like in a way like that fan is rotating in a 2D plane. So why can't we have a plane and will it rotate like that? Then you so it's nice only, but the idea is simple. So we searched online whether there is anything available like that. So we were able to see some volumetric displays. Some is LED matrix cube kind of display. So before coming to that, I will explain a definition for the volumetric displays. Like 3D volumetric displays generate images in a true 3D volume, so that can be viewed from any angle. So definition for any 3D volumetric display. So this is one type of a display, this thing. So it's like the problem with this display is like it's like a LED array is being placed. So the resolution will be very less because due to the wirings to each LEDs. And this is the rotating LED array display. So when we checked online, this is some DIY YouTube channels were making this thing, but in that also we can't give any 3D model and we can't directly see the image. We had to code the 3D model for that display, so it was a little cumbersome. Then we found a brand called Voxon that's in US, and they are making commercially making such kind of displays. But when I checked the price of that display, that was too hefty. Like it was about $6,500, about 5,92,000 here in India. So I know it will never cost that much to make such a display. So we thought to like indigenously make our own display, try to make. So and also this display has uses also. This can be used in educational area for the children, so they can better understand the concepts, and it can be used in any kind of presentational area, maybe architectural presentation or whatever presentation. So they can walk around the display, they can grasp the concepts very easily. So the reason why I chose this project when he said that is because I found it like it's a completely interdisciplinary project. So it has mechanics, it has coding, and it has electronics kind of thing, and it has design aspects also. So that I found it fascinating. So first, I will say the basic working principle of that of this displays just like as a video only. In common video also, we see frames continuously moving. So if the frame per second is 24 frames, we will feel it smooth. In this display also, the same persistence of visions is being used, but in a different way. So after talking talking with him about the project, we found like yeah, the main part it has to rotate. Display has to rotate. So the one of the thing we thought like how can we transmit the power from the non-rotating part to the rotating part, because if we can't give it wires like because the wire will wind it up with the rotation. So we thought of using wireless charging module, but the problem with that is like it's very less ampere, 2 ampere or something it can give. More ampere will give more heat also, and it's very expensive also. So we thought of using slip rings. Slip rings are used in industrial area for these kind of purposes. But when I checked in India also, it's for high RPM, about 900 RPM, it's very expensive also. And through bore slip rings are also not that available in India. When I engaged through online and stuff, I couldn't get it. So we thought of in some other method. It's like we thought of like using bearings to conduct the electricity. Like positive bearing will be there, and negative terminal bearing will be there. So we thought of that idea. Then when we checked in Kanpur market also, we got some conductive bearings. That's the first time I am also hearing there is conductive bearing kind of a category like that. Then we bought it. Oh, sorry, I forgot to bring that bearings also. So first I bought a very big bearing. So when after seeing that bearing, Gautam told, our motor won't rotate, that is very heavy, he said. So I thought, oh, then I got a smaller bearing. It was also like little stiff only. So I said, we will try with the motor. Then we got that. Then the other aspect is how we will show the 3D model to the display. So the basic algorithm we had to make. So simply the algorithm will be like, we thought of like a 3D model will be there. We will find the centroid of the 3D model and we will cut so many sections through the 3D model. And at each rotation of this display, we will show each section. That was the bare minimum concept of that. So that to get a continuous smooth visual, like the persistence of vision is like, so the same section has to come in the same area at least 24 times a second. Then it will be 24 FPS for this display. So since we are using like two displays, I think it will get little confused. So at 180 degree, we can get the same image at the same position. So we can reduce the RPM to 720 RPM to get the 24 FPS. Then, so we'll stop the story in between. I will explain the components of this thing. So in the base of this this product, like this part, if there is a 24 volt 300 watt SMPS that is powering this whole thing, And there is a 24 to 5 volt converter to power the CDNO. The CDNO is helping showing the RPM of the motor. Since it's a BLDC motor, it has some Hall sensors inbuilt in, so it can directly give like the RPM signal that we can calculate with CDNO. And there's a potentiometer to control the RPM, and a display, small display to show the RPM of the motor. And the power control switch is there. And the next level, that is CDNO is a microcontroller.
Here, hold on. Here, what you have done is, whatever RPM you want to do, you are able to get it through this setup which is there at the bottom.
And also there is MDes to power all the circuit. We will supply the power from the bottom only. Then I call this part of that level of that device as a motor base. So in this thing there is a BLDC motor controller. To that also power is being given from the SMPS. And this is a 36 volt motor. There is a 24 volt to 36 volt converter. The reason why I use this because when I was ordering this motor, the website was saying it was 24 volt motor, but actually it was a 36 volt motor. So that's why I had to convert 24 to 36. Then this is the first. This is a conductive ball bearing that we have said. It's a positive terminal of the power supply, and through this there is a ball bearing connector will come. This is the first design of that ball bearing connector. So there is a metal terminal here, so it will get the positive current, positive output. Then is this part. In this part, there is a negative ball bearing. Sorry, there is a slight mistake in the presentation. Sorry. And this ball bearing will go through these two ball bearings to connect to the motor that we have set here to the motor. So this is the first. In this case, there will be the Raspberry Pi and the components like the power converter components that we'll explain later. This is the first design of the Raspberry Pi box. Sorry, because I just remodeled everything as I was renewing the design. I didn't store the earlier design. That's why I'm showing like this. Sorry for that. And this is the component inside the Raspberry Pi box. So it's a Raspberry Pi, and above it there is a like a hub 75 connector. Hub 75 connector means the connector to connect the display to the Raspberry Pi. And I have put the USB 2.0 extension from the Raspberry Pi to the top, because when I searched online at first, I read like the Type-C port of Raspberry Pi can support data transfer, but in reality when I checked, it couldn't. So in order to make the usability easier, I put the USB port to upside. Then there is a 10,000 microfarad capacitor to control, in the sense, the small variations in the supply to the Raspberry Pi, because Raspberry Pi will get restarted even there is small variations in supply. So this is a 24 volt to 5 volt buck converter to be used by all this setup. Okay, so the reason why I am not transmitting 5 volt from the bottom to up, because while rotating there will be resistance, so that will affect the power supply. The 5 volt won't be transmitted up, so I am transmitting the 24 volt to 5 volt within that rotating block only. And there is the carbon rod to fix that display. And this is the display area. There is like a base to which two displays are connected like alternately, and there is this is a rod and carbon rod and the Raspberry Pi top cover. So after all this setting up, my plan was to make a crude model of this device for the tech ready. So I was saying to Gautam, it's easy, like everything has been sorted, the ball bearing, power supply is done, then the coding algorithm also we know. It's easy, I said to him. But at the first rotation, I was rotating it slowly, so it was working fine. So I was very happy. When I slowly increased the RPM, then suddenly, katak katak, vibration started, it broke. Then I was like, it was just two days for Takriti, so I couldn't complete for the Takriti to show in Takriti. So the reason behind the vibration is due to the non-uniform mass distribution inside that Raspberry Pi box. It's like when the mass is not uniform, while rotation, centrifugal force, the uneven centrifugal force will generate. That will cause the vibration and it will break. So we had to redesign the bearing, ball bearing connector. So we included a flange to better resist the vibration. And also we redesigned the Raspberry Pi case. Like I showed that a black box earlier, we redesigned it to a more symmetrical shape. And also I weighed each component and found the weights of each component and calculate the density, like overall density of each component, and was able to calculate the centroid of the system with using a scripting grasshopper. Then I also calculated the weight that should be added so that the system centroid will coincide with the center of the whole geometry of this Raspberry Pi case. Then it's like so that part is done for the hardware. Then to access the wireless, like the Raspberry Pi is just a CPU. So in usual case, we have to connect the monitor and stuff to use the desktop of that, but that is difficult. So I thought to have a wireless desktop access to the this Raspberry Pi. So I used a VNC server and a FileZilla. There's a VNC file transferring software. So it uses Wi-Fi to transfer the files and the desktop of the Raspberry Pi to our laptop. So that just need the Raspberry Pi and the laptop should be connected to the same Wi-Fi network. Then the next task was to make the software that the concept we earlier discussed to cut through the sections. The sections will rotate through the 3D model, and that sections will be shown in the display. So this software will cut the 3D model into slices. So we can select the OBJ file. OBJ file is a very common 3D modeling format, and we can get we can set the angle at what angle we should slice the model, and we can check the resolution according to the resolution of the display. Our display is 64 into 64 resolution. Then we can slice it. We will get a zip file containing all the sections. And the next is the software to the driver that will help us to show the 3D model in the display. So this is while rotation of the display, this software should show the sections at the correct angles. For that, we are getting the angle from. Oh, sorry, I forgot to give one sensor in this thing. I will go back. So here there is a read sensor that's used to calculate the the RPM of the rotating part. Because why we are calculating the RPM again, because we can't transmit this the RPM we earlier calculated from the CDNO to the rotating part easily. For that we have to use other wiring also. So it's better to calculate the RPM of the rotating part and supplies to the Raspberry Pi using this read sensor. So the read sensor will work in a way where whenever there is a magnetic field coming, it will give like a high output. So we can calculate the RPM. I will go in front. So in this thing, so the basic logic of the software is like, suppose in the zip file we have given there is only 2 JPG. So this thing has 2 displays. So while in the rotation, from the first part of the rotation, the PNG 1 will be shown to the display 1, and the PNG 2 will be shown to the display 2. But after 180-degree rotation, the back display will come in the front. So the PNG 2 will be shown on the display 1, and the PNG 1 will be shown in the display 2. So it will cycle like that in each complete 360-degree rotation. So challenges while developing the software to this display also, we faced some challenges. It's like we used a RGB matrix library for this thing, but this display there is option for parallel connection and chained connection. So what that means is parallel connection, we connect the two display directly to Raspberry Pi. Chained connection in the sense we will chain the display, then connect to the Raspberry Pi. But the parallel connection is better because it will give more refresh rate for the display. We need high refresh rate for this display. But when I checked the parallel connection for this display, the code I written, I was like, it is like compiling well, no errors. Logic I also thought it's working, but it's showing weird result on the display. Then I gave the default example code that's been supplied with the display. Even in the without parallel mode, it is working fine. With parallel mode, it's not working. So I was like, oh, what should I do if everything is going waste? Then I thought to give it a chained display mode. For chain display, we had to chain the wiring also. But when I checked the chain display, thankfully it was working well. So I had to open that display part again and also like chain the wiring. Then after that, I thought like I said, we can connect the Raspberry Pi wirelessly with our laptop. But for that, we need to have the same Wi-Fi network. But for connecting the Raspberry Pi to any Wi-Fi network, we also have to connect the monitor. So in order to avoid that, I thought to like already I have given a USB port above it. So I thought to give a code that will give the available Wi-Fi networks in this thing. So we can log into the Wi-Fi and we can easily get the wireless display here. So that's for the usability aspect. So I think most of you may have got the workflow of this thing. Anyway, I will explain the workflow again. So we had to make a 3D model and the OBJ file has to be uploaded to the section software. So we can section it up in the angle 10 degree or whatever. Then we can turn on this device and we can connect to a Wi-Fi, and same Wi-Fi can be connected to the laptop. And in the laptop, we can turn on to the real VNC software and FileZilla. Using FileZilla, we can transfer the zip file to Raspberry Pi. And while turning on that device itself, it will turn on this software. So we just have to choose the section that we are transferred using FileZilla in the real VNC and just turn on the motor. It will rotate. At that time, we can give the RPM threshold. That way, I will say some problems with it now. So it will start showing the 3D sections. So this is the first demo of this thing. In this also, when we shoot with phone camera, it won't give the correct output because of frame rate issue. But in real eye, it is much better. So the problem with this thing also, in the first thing I was able to get first prototype I showed it broken. It was able to get 250 RPM only. But this modification and the weight redistribution, we were able to get 480 RPM. But that can be increased. That we will discuss later in the next slide. So we can get only 480 RPM. So it won't be that smooth the visuals, but we will get an idea of the display works. So what we think to improve it again is like we can. I said I had got a big bearing at that time, but working with this bearing, I got to know it's like the whole weight of the bearing is not taken by the motor; it's taken by the structure itself. So the motor don't has to give that much power to rotate the bearing. So we'll use the big bearing. So it will increase the system weight and also it will increase the inner radius of that rotating pipe. So that will reduce the centrifugal force. And we are planning to shift this box in between the two bearings so that now it is acting as a cantilever kind of system. Top is not supported. So the non-uniform mass will go in between the two bearings. So it is like a two-sided supporter system. So it will oscillate less, and only the display will come on the top. So it's a uniformly, almost uniformly weighed thing, the display part. And we are also planning to change the shape of the device to a dome shape. Actually, the dome shape will absorb the vibration better. So we are planning to do that in later stage. So that's all about the presentation, and I hope all liked it. Thank you for attending the presentation, and we'll show the demo here now.
me the numbers.
So I will show the software for sectioning, but I'm not sectioning now. So this is software for sectioning. We can upload the OBJ file to this, and we can get the sections like a zip file output. So the output will show the PNG of all the sections cut, and it will also give a like a section output, and we can open the real VNC to get the wireless input.
OBG would have cut at various angles, right?
Hmm?
OBG file, whatever you show, for example, it's a cylinder, it would have cut at multiple angles.
That software maybe yeah.
And each angle becomes one frame for you.
Yeah.
Now we are reconstructing the image.
Yeah. So this is a wireless connectivity to the Raspberry Pi, and it's already on the software to select the file. So we have already uploaded that section file to this thing. So I'm just choosing it.
Is this table stable?
Hmm?
Table is it stable?
I don't know. I will hold it.
It may should not vibrate. This table we cannot test. Vibration was the main issue. This is the third or fourth position.
It has
Maybe we can place it on the floor. That would be better.
Yeah,
Hold the table. No, I think it's better to place it on the floor. Yeah. Please hold it. No. Let's place it on the floor. Sure. Place it. Yeah. I don't know.
Table is vibrating. Yeah, but why do table vibrate? There has to be a.
ஆமா இது வந்து ஒரு 500 ஆச்சு. Actually, we need to achieve 720 RPM minimum, but it's not going beyond 455. Motor is capable, but we are not flexing it to maximum power.
My only worry is right from the beginning, I have been telling Jabeen this, the weight to whatever is there should not fly off. And I was always telling him word for us. The only sacrifice is resolution.
Yeah, it's getting exactly. Not resolution, persist resolution.
Oh.
That the effect we won't get. Else it will be like we can actually check that.
It's correct.
It's restarted now. We turn on after some time.
This is one problem. Like whenever due to small jerks, that connection it actually misses and then the Raspberry Pi resets. We tried putting the big capacitor and all those things, but still Apple grade production we are not able to do.
That is why that is sold at 7 lakhs.
But still, given some facility we can do. This we did for with zero budget, meaning my.
He said thanks to you, right? If you would have said you would have worn a shirt where it is written Gautam Prabhakar.
But still, I think we can work on it. See, on the top, it's actually wobbly, right? If you can look at the frame and then pivot it, I think.
Yeah, listen.
So this is, yeah, basically it's a torus. What is a torus? Torus. It is made by combining circles together. But if we increase more RPM, then more FPS, it will actually look like that. You won't be able to figure out. So the best part about this, you can actually walk around and then everywhere the 3D, whatever angle. Let's say Ashwin is actually rendered here. Ashwin's side part will be seen here and then side here.
He plays it safe. See, if you would have taken a non-axis part, then you could have seen it. And the axis cement part, yeah.
Because it's now.
Yeah.
This was the prototype.
Oh, that's it.
But now the thing is, the platform is ready. We can render any object. What other objects do you do? One more thing you were saying.
Yeah.
I mean, people want to actually take a look.
It is not continuously uniform. Sir.
Yes.
What is happening is, you can see from this thing, frames are getting distributed. See, now it looks very close. After some time, it gets
Yes.
Yeah, because the vibration, it's not to RP.
Like a slice, like a string.
Yeah, we can do.
But the speed is less. It's because of same frame you are feeling this much. Then you may not feel the feel.
Yes.
At one moment there is less now
And then that's because of the vibration, the RPM will change. So the mapping will change.
Yeah, because we have a set waves of guidance.
I think if you have
we
a
tried to be
connector at the top also,
Yeah, that's what.
See, that will make it more
If you have a connector at the top, then the earlier problem will repeat. Now you will have a wire which spins. So if you put
This
the
is a
stem on
thermal,
top, he has to balance the stem with respect to the weight which is.
No, that's
it needs the counterbalance.
Yes, it needs a control. Like what is there in the bike?
Yeah.
Yes, good. Good at all.
Right now, it is at 570.
There is tea, there is coffee.
Thanks.
You already know.
Generally.
Think of people you have to sponsor. Huh? No.
Department should sponsor.
EPGC will sponsor.
But then let's go. Let's
I would like to change the design also.
no, change.
Because we need your printer again.
We'll give you a spool. You print this and give.
On the way on. You graduate first. You must stay in. That's good.
Video, so in video, you cannot actually capture it.
The video, see, there is a frame rate for the video also.
Yeah.
So that will not match. And then it is good.
Maybe 120 FPS.
Hmm. Hmm. Okay.
Hello? Yes, sir.
Can also be reduced. So 550 or 600 I want. We change it that way. That something will be closer, sometimes will not go.
Adaptive. Adaptive. Is the display on the both sides?
Sure.
That's why it is, but it needs to happen. Otherwise, and then before security happening, that will
Sure.
Because then we attach the acrylics kind of container.
Exactly. We need to have more weights on the tire. Should do the cycle. The mass of the tire, it's max at the tire ring, but in the center is.
The thing is quite crazy because in the it's box, right? And the mass is down like so it's like each part will different configurations. That's why I thought change the bottom.
அவ்வளவுதான் படம் காட்டுற பத்தியா என்ன அர்ஜுன் போட்டு அர்ஜுன் அஸ்வின் எவ்வளவு படம் காட்டுறான் பத்தியா அதுல ஒரு சமோசா போட்டு சொத்து
நான் சொல்றது ஆக்சுவலி 3D மாடல் ஆஃப் சமோசா
அரேஞ்ச் பண்ண
Without the it was going above the cover.
The long exposure.
To completely make a dead weight of it. So we need to take this rotation full of strokes. And if you have anything else,
Yeah, that we can do.
no, just make a support weight. You need to have a mirror of the same component.
In that way, I plan to give more like a two-sided support for this thing.
Okay, so I'll record like what if you pick the whole box completely?
And also if you like one component here.
Stand. A complete space. The motion also will be very minute. So you build the complete box.
Don't do the much centrifugal force of the each component. It's not moving, but there will be a centrifugal force of
It's
the.
basically like density also. So you have a raspberry Pi. There is on the counter side of the raspberry Pi, there is nothing.
There is a one component.
You try to manage it manually. What I'm saying is it will completely with sand or something. Some sort of
Even then,
some sort of solution for the wobbling. You need to
The components that are there, the same, still the weight will be.
But you will be using
Using that.
Like,
counterweight bar.
Yeah, that will.
And would have like counterweight.
Then you have to make it like a pocket. You have to measure the whole space. So that the seam. That is okay. But if you fill it, it is the same. Which is that with measuring each component getting the same. And then they write that it end up the same thing. And then finally you get the negative mark. What is to install what distance. And
that is, I already have the mark, but it's not, won't be that much accurate, but might have a different accuracy.
So using evolutionary optimization in you can like optimize that to approximately reach that level. So the wobbling will reduce.
What if you put an axis on the top also?
And that's the, then I have to connect to the acrylic sheet or something, there is less top. So that's why I thought, change this part is causing the problem, this part to the both support area, in that it will change the both bearing, between both bearing. So that part is between two support. On this display is going to become the support. Let's say, so it will reduce drastically.
So if this base was this large, it would be stable.
no, it will have more work.
More omega square, there's this R left. So when you extend this, extend the mass of this, you don't need to put any constant. You extend that, you have to go like this. So you must have seen those tops, which have a wider base and a thinner bottom. You just spin it like this. No, no, it low RPM. No, not wavelength. These are the other types. So there's no tangible base, they have wider base and the base is
But it will defeat the purpose. This is the whole volume. You are asking this volume. Then
you can extend. This being the same, extend this, then you have a
Idea and
one side. That is coming from everything else, but there is
have a dome kind of structure.
Between two bearings. So it is like.
Yeah, that's good. That's good.
What is the vision? Because it's not controlled. How does the I added just for me. I added I want in this. Who was the examiners? Currently the it's giving an exam which are in the
So positive.
Regardless of the
Both of us has a rotate. By the way, great job. A great job. Very something. Display is standing before on that display was like a standard display or you had to arrange the display?
Yeah,
How many?
Thank you so much.
Screen is a standard. What is the LED one? They combine more of them. Interesting. I think if you take those stances, transparent displays, black, next project. Good at road man.
This whole thing came out like this nice wholesome product. That's this. Achieving that is not a small.
This rubber band. I could It takes a long time, but in that final output, the mass they can get will be accurately
The last thing was change
yeah,
Just when the Rashmi
because it will help.
like you saw even Boxstar displays had like, I mean, I don't know if it's connected on the top, but they had glass on the stabilization of the top. Yeah, it's possible on the top, they also connected. It's like, why would you not connect?
I mean, yeah, where do you actually connect that? I think that keeps it. And then I so the problem is that I took that then I put I think all that I tried cutting my message sheet with capture. Maybe just for
കഴിഞ്ഞ നെക്സ്റ്റ് ടൈം
എല്ലാം കഴിഞ്ഞു ഒരു എക്സാമിനേഴ്സിന്റെ ലിസ്റ്റ് ഇല്ലേ അതിങ്ങനെ വെയിറ്റ് ചെയ്തോണ്ട് ഫസ്റ്റ് അതാ ഇവിടുന്ന് പോയി
ജബീൻ കൺഗ്രാറ്റ്സ് പണ്ടൊക്കെ ഞാൻ ഫോട്ടോ എടുക്കും ഇപ്പോൾ നമ്മുടെ ഫാന് പറഞ്ഞ പെർട്ടിക്കുലർ ഷട്ടർ സ്പീഡിൽ മാത്രമേ സ്മൂത്ത് കിട്ടുള്ളൂ. സ്മൂത്ത് അല്ല, ഫോട്ടോ എടുക്കുന്നതാണെങ്കിൽ ഒരു പെർട്ടിക്കുലർ ഷട്ടർ സ്പീഡ് ഫ്രീസ് ആവും. അപ്പൊ ഇവിടെ നീ പറഞ്ഞില്ല 720 RPM 24 FPS ആവും. അത് മനസ്സിലാക്കി.
Then we get for it. Say what? That's what he's gonna do. That's what the idea is. You have
Congrats.
Because we did not give vote of thanks.
Acknowledgement.
So I will have to end the session.
Okay.
Jabeen, can you take it back?
Oh, yeah.
Nice.
Then recording start what's up?
എന്ത് റെക്കോർഡിംഗ് ഇതിൽ സ്റ്റാർട്ട് ആയില്ല അയ്യോ
Teams recording is very good. How is the video recording in Teams? Is it good?
It's actually good only.
Does it require internet or without internet?
It requires internet, yes. Jabeen's defense.
And you added like some.
Stop sharing. What the fuck? We did not record, is it? Oh yeah, it's recording. How to stop recording?
In the meeting, it will stop.
What? I think end the meeting, it will record, I guess.
are you sure?
So it happens in
Yeah.
Zoom.